Good evening, everyone. Good evening, everyone. Welcome to Goscore Learning. We are the fastest growing edtech industry in the Middle East, and our main aim is to provide quality education for all. We are here to make your learning easy. I am Dhanya Rakesh, teacher from the Department of Chemistry, Goscore Learning. I am a pharmacy postgraduate with more than 5 years of teaching experience. You all know that today we are going to discuss the third chapter of grade 12 chemistry, that is chemical kinetics. Okay, before entering into the chapter, I would like to give a brief introduction about the entire syllabus of grade 12. You are already aware about it. It's mid of the academic year, so you know that how many chapters are there. Even though I will give you an introduction about the whole chapter and the weightage marks. We have inorganic as well as organic chemistry, and the first chapter is solution, electrochemistry, chemical kinetics, D and F block elements, and then coordination compound. And coming into the organic chemistry, it is haloalkenes and haloarenes, alcohols, phenols and ethers, aldehydes, ketones and carboxylic acids, amines and biomolecules. If you look at the weightage marks, we can expect more questions from the second chapter, that is electrochemistry. Okay, and why I choose this chemical kinetics chapter is, it is very interesting chapter, as well as you can easily get the concept in that chapter. If you get the concept clear, you can score good marks in the examination, right? So let's see what are the portions that we need to cover in the chemical kinetics chapter. That is mainly the rate of a reaction. Okay, and the factors. What are the factors that affect the rate of reaction? Then comes the order and molecularity of reaction, and the rate law and specific rate constant. Then the integrated rate equations and half-life, concept of collision theory, activation energy, and Arrhenius equation. So these are the main things that we want to cover under this chapter. So are you all ready? Can we move to the chapter? Okay. So what about chemical kinetics? What is chemical kinetics? We see a lot of reactions every day, right? Is all of them proceeding in the same speed? Some may take a fraction of seconds. Some reaction will take 1 day to complete. Some will take more than a day, isn't it? So what we understood from that? The speed or the rate of reaction is varying. For each reaction, it will have different speed. So there is one branch of chemistry that deals with the speed or rate of a chemical reaction. That branch is the chemical kinetics. So chemical kinetics is the branch of chemistry which deals with the study of reaction rates. Reaction rates means the speed of the reaction and its mechanism. Okay, so you are clear with what is chemical kinetics. That is the study of the reaction rates and their mechanism. That is the things we are going to learn in this chapter. Okay. Now see, during a reaction, we know that we have learned in the 10th standard that reactants, what is product, what is the chemical reaction and everything. So during a chemical reaction, the reactant get converted into product, right? So if you consider a reaction, that reactant changing into product at the initial time, that is the time t is equal to 0. At time t is equal to 0, there will be more reactant because the reaction not yet started, right? So here the reactant concentration will be maximum. And what about the product? It's at 0 time, the reaction not yet started. So the product concentration will be 0. that is at 0 time. Okay. Then after sometimes just after 20 minutes, if you check the concentration again, that is time is equal to 20 minutes. If you check the concentration of reactant, what you can see? Then the concentration of reactant will start to decrease. Why? Because this reactant changing into product. Okay. So here we can see after 20 minutes, the concentration or the amount of reactant is decreasing. Okay. But at the same time, the amount of product, formation of product will occur and the concentration of product reaches to maximum or it is increasing. Okay. So we can express the speed of this reaction, that is the rate of reaction, both in terms of reactant as well as in terms of product. That is simply the change in the concentration of reactant or product with that particular time. Okay, or the time taken to complete the reaction. So we can express the rate of a reaction as the change in concentration of reactant or product by time taken. Got it? So rate of a reaction, we can express the rate of reaction both in terms of reactant as well as in terms of product. Now let's see, if you are expressing it in terms of reactant, there a decrease in the concentration of reactant. That means disappearance of reactant. So if you express the reaction in terms of reactant, we will mention it as decrease or disappearance of reactant. So we can express the rate of reaction as decrease in the concentration of reactant by time taken. At the same time, if you are expressing it in terms of product, what it would be? There is a appearance of product or increase in the concentration of product, right? So we can say the rate of reaction in terms of product or appearance of product as increase in the concentration of product by time taken. So if you plot a graph like taking the concentration on the y-axis and time on the x-axis, what it will be? Initial stage, that is when time t is equal to 0, the concentration or the amount of reactant will be higher. So as the time proceeds, what happens? The reactant concentration starts decreasing, right? So we can say this is the graph for reactant. Okay. At the same time, what about the product? As the time proceeds, initially when time t is equal to 0, the product concentration is 0. As time proceeds, the concentration or the amount of product increases, right? So this will be the graph for product. So when you plot the concentration versus time, we can see that for the reactant, the concentration decreases, and for the product, the concentration increases with time. Okay. If so, can you tell what is the unit of the rate of a reaction? What is there in the numerator? Numerator, it is concentration. How we will express the concentration? In terms of moles per liter, right? What is there in the denominator? That is time. Time we can express in second or in minutes. Okay. So we can say that the unit of rate of a reaction is moles per liter per second. Okay. Or moles per liter per minute. Then what about the cases of gaseous reactions? For gaseous reactions, we will express the rate in terms of atmosphere. Atmosphere per second. Okay. So don't forget the unit of rate of a reaction. It will be very useful for your calculation part. Because when you get the answer, you should mention the unit of rate, right? Otherwise, you will lose the mark there. Okay. So keep in mind that the unit of rate of a reaction is mole per liter per second or mole per liter per minute. Okay. Now, We can say that rate of a reaction in terms of average rate and instantaneous rate. Then what is this average rate? You may have learned in your lower classes that when you are traveling from one place to another place, we have to calculate the average speed of our journey. You may learn in the physics classes, right? So same like that, here during a chemical reaction, we will find out the average rate of a reaction for a period of time, for a particular time interval. Okay, during that particular time interval, what is the speed of the reaction? That is what? Average rate of a reaction. That is the change in concentration over a time period is what we called average rate. Okay, if you consider the reaction, A plus B giving C, how we can say the average rate of the reaction, the rate average, or we can write it as R average. Average rate we can express as the change in concentration of either reactant or in terms of product. Here if you consider the reactant A, how we can say the change in concentration of A with that time interval. That time change we can denote it by delta T. Delta means change in time. Here we are considering a particular time interval. So the change in time value will be slightly higher value. That's why we are putting the sign delta here. Okay. Delta T by what we will do for this change in the concentration of reactant A. That is change in, for writing the concentration, we have to put a square bracket. Okay. So if you write square bracket and inside that A, that means it indicates the molar concentration of reactant A. Okay, here A is the reactant. Okay, so what it will happen? Its concentration is reducing during the time. So while writing the rate, we have to put a negative sign here. Okay, because A is a reactant and during the reaction, the concentration of A is reducing. Similarly, how we will write the average rate of reactant B? How we will write the average rate in terms of reactant B? It will be minus delta concentration of B by delta T. Okay, same way we can write the average rate of the reaction in terms of product C. You need to put a negative sign in C? No, right? Because C is the product. During the reaction, what happens? The product concentration is increasing. So we can write the rate in terms of C as delta concentration of C by delta T. So this is the way of expressing the rate of a reaction, average rate of a reaction. Did you understand it? Okay. So that's about the average rate. But then what is this instantaneous rate? From the word itself it's clear. Instantaneous rate means the rate of a reaction at a particular instant. Okay, at a particular time, what is the rate of the reaction? That is what instantaneous rate. We will measure the change in concentration of any reactant or product with a particular time. That is what the instantaneous rate. Okay, so when we plot that graph, we have plot the concentration versus time graph, right? If you want to find out the rate of a reaction at this particular time, here at this time, if you want to find out the rate of the reaction, what we will do is we will extrapolate this time to here and we will get a plot in the graph, right? So from that plot, we will draw a tangent line and we will find out the slope of that line. Okay. See, here if you plot that graph for reactant, okay, that is concentration versus time. If you want to find out the particular rate at the particular moment, we will draw a tangent line like this and we will find out the slope of that line. Okay, what is the slope? Slope will be equal to dy by dx. Okay, here what is in the y? Change in the concentration. What in the x-axis? Time. Here we are measuring the change in concentration for a particular time. So the change in time will be very lesser value, right? So no need to write the delta here. We can write dt and the concentration as we mentioned for the average, like whatever the reactant, if it is A, minus dA by dt. Okay, that's for about the instantaneous rate. Okay, so for instantaneous rate, we are measuring the change in the concentration at a particular time or particular instant. Okay, we will plot the concentration time graph, and from that graph, at what time but reaction is proceeding for 20 minutes. If I want to find out the rate of the reaction at 10 minutes, I will plot a graph on that and we will draw a tangent line and measure the slope of that line. With that line slope, we will get the rate of the, instantaneous rate of that reaction. Okay. Now let's see a question that we want to write the formula for expressing the rate of reaction, that is nitrogen react with hydrogen to form ammonia. Okay, here only point that you have to keep in mind is that check that for hydrogen there is a stoichiometric coefficient 3, right? And for ammonia also there is a stoichiometric coefficient 2. In a balanced equation, if there is a stoichiometric coefficient, while writing the rate of that equation, you have to take the reciprocal of that stoichiometric coefficient. Got it? See, you are writing the rate of this equation. Rate is equal to, in terms of nitrogen, how we can write it? The concentration of nitrogen. How we will write it? By putting a square bracket, right? D N2 by dt. As nitrogen is the reactant, we have to put a negative sign here. Okay, so the rate of reaction in terms of nitrogen is rate is equal to minus D concentration of nitrogen by dt. Then look for the rate of reaction in terms of hydrogen. For hydrogen, it's also reactant, so we have to put a negative sign there. Okay, but for hydrogen, there is a stoichiometric coefficient there. So if there is a stoichiometric coefficient, what I told, we have to take the reciprocal of that. Then it will be minus 1 by 3 the concentration of hydrogen by dt. You got it? Same way, how we will write the rate of the reaction in terms of product. That is, for product also there is the stoichiometric coefficient 2. So how we will write it? For product, do we need to put a negative sign? No, right? Because the product concentration is increasing during the reaction. So we can write it as 1 by 2 the concentration of NH3 by dt. See how simple it is. This is the way of expressing the rate of that reaction. Clear? We can express the rate of reaction both in terms of reactant as well as in terms of product. Okay, so can we move on to the next question? Now, here we have for the reaction 2N2O5 giving nitrogen dioxide and oxygen. The rate of the formation of NO2 is given in the question as 2.8 into 10 the power minus 3. Here see, what is this? The unit of rate, that is mole per liter per second. Okay, and we want to calculate the rate of disappearance of N2O5. So we want to calculate the rate in terms of reactant. Okay. So here first we can write the rate of the reaction. See how we will write the rate. Rate is equal to, in terms of reactant, see here for the reactant N2O5 there is a stoichiometric coefficient. So how we will write the rate in terms of reactant? We have to take the reciprocal of stoichiometric coefficient, right? So 1 by 2. Since it is a reactant, we have to put the negative sign there. Negative minus 1 by 2 d concentration of N2O5 by dt. Or we can write it in terms of product. So for product, how it will be? For the product nitrogen dioxide, there is the stoichiometric coefficient 4. So how we will write the rate of the equation? It will be 1 by 4 d NO2 by dt, right? So in the terms of oxygen, how we can write? It will be, there is no stoichiometric coefficient, it is 1. So it can be written as dO2 by dt. Now see, the question, it has given the rate of formation of nitrogen dioxide. So we are provided with the change in the concentration of nitrogen dioxide. dNO2 by dt, it is given as 2.8 into 10 the power minus 3. So what you want to find out? It is the rate of disappearance, that is minus dN2O5 by dt. How we will calculate? Simply by taking this, right? So we can rewrite it as 1 by 2 dN2O5 by dt is equal to 1 by 4 dNO2 by dt. Okay, so you want to find out this one, that is dN2 minus dN2O5, the disappearance of dinitrogen pentoxide. Okay, is equal to, this 2 will be cross multiplied there, so it will be 2 by 4, that is this 2. Cross multiplication, right? Then it will be 2 by 4 into, what is the value of this dNO2 by dt? That is 2.8 into 10 the power minus 3. So 2.8 into 10 the power minus 3. So after doing the calculation, it will be like 2, 1.4. So what will be your final answer? It will be 1.4 into 10 the power minus 3. What is the unit? Is the rate? So mole per liter per second. That is your final answer. That is the rate of disappearance of N2O5 is 1.4 into 10 the power minus 3 mole per liter per second. So can we move on to question that will be on the same mode? Okay. Check it. For the reaction N2O5 giving 2NO2 plus half oxygen. Okay. The rate of dissociation of N2O5 is given in the question as 5.6 into 10 the power minus 5. Okay. So you want to determine the rate of reaction, rate of formation of NO2 and rate of formation of oxygen. See how we can write the rate. Before writing the rate of the reaction, check whether there is a stoichiometric coefficient is there or not. Okay, if there is a stoichiometric coefficient, have to take the reciprocal of that. Okay, and in terms of reactant, while you are writing the rate in terms of reactant, you have to put a negative. Okay, so try to write the rate of the reaction. The rate is equal to what it will be? In terms of reactant, we can write it as minus d N2O5 by dt. In terms of product, for NO2, there is a stoichiometric coefficient 2. So it will be 1 by 2, reciprocal of the stoichiometric coefficient. 1 by 2 d NO2 by dt. Right. So what will be in terms of oxygen? See, here the stoichiometric coefficient is 1 by 2. So when you take the reciprocal, it will be 2, right? So it will be the rate of reaction in terms of oxygen. It will be 2 into the concentration of oxygen by dt. Now, what we want to find out? The rate of formation of NO2. And what it is given in the question? It is given the dissociation of N2O5, that is minus D N2O5 by dt. It is given in the question as 5.6 into 10 the power minus 5 mole per liter per second. Okay, now we want to find out the change in the concentration of nitrogen dioxide. We want to find the rate in terms of nitrogen dioxide. Okay, so here what we want to find, we have to substitute the value in this equation. Okay, so if you want to find out the d nitrogen dioxide by dt, it will be equal to 2 will be multiplied here, right? So 2 into d into O5 by d. So it will be equal to 2 into, what is the value of d into O5? It is 5.6 into 10 the power minus 5. So your final answer will be, what will be your final answer? 11.2 into 10 the power minus 5. 11.2 into 10 the power minus 5. What will be the unit? Mole per liter per second. Okay. So, is that clear for everyone? If so, just try to find out the rate of formation of oxygen by using the same technique, right? Here, this value is given and we want to find out the rate of formation of oxygen. How we will do it? That is, we are provided with 2.8, we are provided with 5.6 into 10 the power minus 5 is equal to 2 into concentration of oxygen by dt. Then what will be the rate of formation of oxygen? It will be 5.6 into 10 the power minus 5 divided by 2. Complete this answer and write your answer in the comment box. Okay. So, this is about the rate of the reaction and how we are expressing the rate of reaction in terms of reactant as well as in terms of product. I hope this is clear for everyone. Now, can we move on to the next portion? That is the factors affecting the rate of a reaction. Okay. So, what are the factors that affect the rate of a reaction? There will be different factors which affect the speed of the reaction. Okay. The first one is the concentration of reactant. Just think what will happen if you increase the concentration of reactant. You increase the concentration of reactant, definitely the reaction rate will increase. Okay. So, we can say that concentration is directly proportional to, the rate of reaction is directly proportional to concentration. Whenever there is an increase in the concentration of reactant, okay, there will be an increase in the rate of the reaction. Okay. And about the temperature. Whenever we increase the temperature, what will happen for the rate of reaction? It will also increase. Do you know reason? Because when we increase the temperature, the particle will get more kinetic energy. They will move faster and collide with each other. So, the reaction rate also increases. Okay. So, we will discuss this one in detail in the next part of this chapter. Okay. And also the presence of catalyst. we may have learned in our lower classes that catalyst will increase the rate of reaction. Do you ever think how this catalyst increases the rate of reaction? We will learn detail in this chapter, but I will give you a brief idea that catalyst will lower the activation energy. The activation energy get lowered, the reaction proceed in a faster way. So, thereby the catalyst, if there is a catalyst in a reaction, it will speed up the reaction. Okay. So, these three things we want to study in detail in this chapter. Okay. The rest all things, the nature of the reactant. We know that during a reaction, there will be formation of bonds and breaking of bonds. So, of course, the nature of the reactant depends the rate of reaction, right? And next factor is the surface area of reactant. There may be certain reactions that takes place on the surfaces. So, there if the surface area increases, of course, the rate of the reaction increases, right? Next one is the effect of radiation. What we will call further reactions that takes place in presence of light. That is what we call photochemical reaction. So, this factor is mainly for photochemical reactions. So, you have to mainly concentrate on these three factors, how these factors affect the rate of a reaction. So, what are the factors? That is concentration of reactant, temperature, presence of catalyst, nature of the reactant, surface area of the reactant, and finally the effect of reaction. Effect of radiation. Clear? Now we can move on to very important portion in this chapter, that is the rate law. Okay? So don't look on this. I will give you the explanation, then we can see what is the rate law. Okay? See, consider the equation AA plus BB C plus DD. What is the small letters? The small letters indicate the stoichiometric coefficient in the balanced equation. Okay. And what is this big letter? This A and B indicate the reactant, and C and D are the products. Okay. So, this one we have learned that the concentration of reactant influence is the main factor that influence the rate of reaction. So, whenever there is an increase in the concentration of reactant, the reaction rate also increases. So, we can say that the rate of reaction is directly proportional to concentration of reactant. How we will write the concentration? Square bracket, right? Concentration, what are the reactants here? A and B. So, concentration of A and B. Okay. Now, we can change this proportionality, that is rate is equal to K into concentration of A and concentration of B. Okay, this K is called as the rate constant. This K is the rate constant. Okay. Now, you want to know an important thing, that the rate of the reaction we always calculated based on the experimental data. Okay. We don't merely predict the reaction rate by looking into the balanced chemical equation. The rate of the reaction is determined based on an experimental data. Okay. So, here during the rate of the reaction, each of these concentration terms raised to an exponent, and this exponent values, that is x and y, this may be equal to the stoichiometric coefficient or may not be. Okay. So, why we write it as x and y? Because these values we calculated or measured on basis of the experimental data. Okay. For some reactions, it will be equal to the stoichiometric coefficient. So, this x and y may be the stoichiometric coefficient or may not be. Okay. So, this x and y are experimental data. Okay, now we will see the rate law. The rate law states that this is the way of expressing the reaction rate, that reaction rate is given in terms of molar concentration of reactant with each term raised to a power, and this power may or may not be same as the stoichiometric coefficient. You got it? Okay. So, the rate law is the expression in which the reaction rate is given in terms of molar concentration of reactant and each term raised to a power, and this power may or may not be same as the stoichiometric coefficient in a balanced chemical equation. This is the very important portion in this chapter, rate law. Okay. Now see order of a reaction. What we write the rate law equation? That is, rate is equal to rate constant K into concentration of A raised to exponent X and B raised to exponent Y. See here, if you add this exponent, that is X plus Y, the sum of this exponent, that is what the order of that reaction. Okay, order of reaction is nothing but the sum of this exponents in the rate law. Okay, so we can say that the sum of powers of the concentration of reactants in the rate law expression is called the order of that reaction. We have find out this X and Y values experimentally. So, the order of reaction is an experimental quantity, right? So, this X and Y value may be 0 value, 1 or any half fractional values, whatever it may be. It depends on the type of the reaction. Okay. If this value is 0, what it indicate? Let's see if this X and Y is 0. Okay, if your order is 0, that indicate this 2 are 0, right? So, how we can write the rate of the equation? It will be rate is equal to K into concentration of A raised to 0 and concentration of B raised to 0. Any number raised to power 0 means its unity 1, right? So, rate is equal to K. Okay, this is for 0 order. So, we can say that a 0 order reaction is a reaction in which the rate of the reaction is not depending on the concentration of reactant. See, here there is any concentration of reactant terms here? No, right? The rate of reaction is equal to the rate constant only. We can say that a 0 order reaction is the such type of reaction in which the rate of reaction is independent of the concentration of reactant. Okay. Same way we can say the any order. If we can, for this reaction we can say that the reaction rate is X order with respect to reactant A and rate is Y order with respect to reactant B. By seeing the exponent we can say that with that particular reactant what order the rate of the reaction is. Clear? Okay. Now see another important term, that is the unit of rate constant. We have already mentioned that the unit of rate of reaction is mole per liter per second. Now see, rate we can write as per the rate law, rate is equal to K, rate constant into concentration of A raised to X and concentration of B raised to power Y. Okay. So, what is the unit of rate of reaction? Mole per liter per second. Okay. That is mole, liter inverse, second inverse. Okay. So, what is this K? K is rate by concentration. concentration of A raised to X and concentration of B raised to Y. Right. Now, you can write it as, we can write it as rate constant K is equal to mole liter inverse second inverse by, what will be the unit for concentration? It will be moles per liter. Mole per liter. For B also it will be mole per liter. So we can rewrite it as mole per liter raised to X plus Y. Is this X plus Y? It is order N, right? So we can rewrite it as, I am writing here, see, it will be mole per liter per second or mole liter inverse second inverse, both are same, right? By mole per liter raised to N. Whenever you get any order of the reaction, if N is 0, substitute the value here. You can find the unit of the rate constant. If you are feeling difficulty to remember this, just remember this one. Mole raised to 1 minus N, liter raised to N minus 1, second inverse. Okay. Try to remember this equation, that is mole raised to 1 minus N, liter raised to N minus 1, second inverse, for finding the unit of rate constant. Okay. So from now onwards, you should always keep in mind that mole raised to 1 minus N, liter raised to N minus 1, second inverse is the unit of rate constant. Okay, are you all clear about whatever the topics we covered? So can we move on to some problems from this portion? Okay. See, find the unit of rate constant for the reaction 2A plus B giving A to B, which has the rate K equal to K into concentration of A raised to 2 and the concentration of B. See, what is the rate given here? Rate is equal to K into concentration of A square into B. Then what is the order of this reaction? Just add this 2 plus 1. Then order, that is N, is equal to 2 plus 1, 3. You can write the rate constant, unit of rate constant, right? What it will be? Simply substitute N equal to 3 in this one. So what will be the answer? It will be mole raised to 1 minus 3, liter raised to 3 minus 1, second inverse. So your final answer will be, yes, mole raised to minus 2, liter raised to power 2 and second inverse. See how easy it is. If you learn this one, you can easily get the unit of rate constant. Okay, now let's go for the next question. That is, a reaction is of first order with respect to reactant A. Okay, and the reaction is of second order with respect to reactant B. Now we want to find out how the reaction rate is affected when we increase the concentration of B to 3 times. See, first we can write the rate of the reaction. Okay, rate equation. It will be rate is equal to rate constant K into, what are the reactants here? A and B, right? Concentration of A. And what it is mentioned in the question? The reaction is first order with respect to A. So what will be the exponent of concentration of A? It will be 1. Okay. And the reaction is of second order with respect to reactant B. So how we can write it as, for B it will be 2. Okay. See, the rate of the equation is rate is equal to K into concentration of A raised to 1 and B raised to 2. Okay. Now see the question, what you want to find out, how the reaction rate is affected when you increase the concentration of B 3 times. We are changing the B 3 times or increasing the concentration of B 3 times, that means 3B. Substitute that B equal to 3B in this one. Then your rate will be, rate is equal to K into concentration of A raised to 1 and instead of B it will be 3B. 3B square. See what will be the change? K into concentration of A into 3. 3 square means it is 9. And concentration of B square. If you rewrite this, you can write it as, you rewrite, this will be 9 into K into concentration of A by A into B square. See, this is our initial rate. This is what happened when you increase the concentration of B to 3 times. What happened? The reaction rate increased to 9 times when you increase the concentration of B 3 times. Okay? Now see the second part of the question, that is, what happens to the rate of the reaction when you double the concentration of both A and B. So for that, what we need to add? We have to change the concentration of A as well as B. Double means 2A and 2B. So rate will be equal to K into 2A into 2B raised to power 2. Right? So it will be equal to K into 2 into concentration of A. 2 square means 4 into concentration of B square. Then 4 into 2 means 8. Will be 8 K into concentration of A of B square. See what happens for the initial reaction rate when you double the concentration of A and B. The rate of the reaction increased to 8 times. Okay. So this kind of questions with different values you can expect for your examinations. So I hope this is clear for you all. Okay, now see one more question. The same pattern. Okay. A reaction is of second order with respect to reactant. What is the unit of rate constant for such reaction? And how is the rate affected if concentration of reactant is reduced to half and doubled? See, a reaction is of second order with respect to a reactant. So how we can write the rate? It will be equal to, rate equal to K into, here only one reactant is given in the question, right? So it will be K into concentration of A. And that particular reaction is second order. That means what will be the exponent value? It will be 2. Right? Then what do you want to find out? What is the rate constant? Unit of rate constant for such reaction. See, order is this. This is a second order reaction. Then what will be the unit of rate constant? Substitute the value of n equal to 2. So, we'll get mole raised to 1 minus 2, liter raised to 2 minus 1. Second inverse will be inverse liter. Second inverse will be the unit of rate constant for this reaction. Okay, now see how the reaction rate affected when you reduce the concentration to half. Okay, so when we reduce the concentration to half value, rate is equal to K into half means A by 2. What will happen for the rate of reaction? It will be 1 by 4 K into concentration of A square. This is the initial one, and the reaction changed to 1 by 4 times when you reduce the concentration to half. You understood this? Try to solve this question and put your answer in the comment box. Okay? Now, let's see one more question. The decomposition of ammonia on platinum surface is a zero order reaction. What is the zero order reaction? Zero order reactions are those reactions in which the rate of the reaction is independent of the concentration of reactant, right? So, this is a zero order reaction. That means, what it indicates? Rate is equal to rate constant, since it is a zero order reaction. Okay, so we can write the decomposition of ammonia. It will be ammonia decomposes to give nitrogen and hydrogen. Okay, see, what you want to find out? What will be the rate of production of nitrogen and hydrogen when the value of this rate constant is 2.5 into 10 the power minus 4. Okay, so we can write the rate of this equation. How we will write the rate of this equation in terms of reactant and in product? Rate will be equal to, in terms of reactant, it will be minus 1 by 2 is dNH3 by dt, and in terms of product it will be the concentration of N2 by dt, or in terms of hydrogen, here 3 is the stoichiometric coefficient. So when we take the reciprocal, it will be 1 by 3 d by dt. Now see what we want to find out. We want to find out the rate of production of nitrogen. See, of production of nitrogen is directly proportional or equal to rate of the reaction. The rate constant value is given in the question, and the rate constant is equal to rate of reaction. So what we can write here? The rate is equal to, this one is very important. How we get this? Because it is mentioned in the question that this is a zero order reaction. That's why I wrote the rate is equal to rate constant. That means the rate of reaction is independent of the concentration. That's why we called it as zero order reaction. Right? So, once we get this value, K is equal to rate. So, we can write it as 2.5 into 10 the power minus 4 is equal to dN2 by dt. That is what the rate of formation of nitrogen will be, dN2 by dt. Now what is the second question? You want to find the rate of formation of hydrogen. That is this 2.5 into 10 the power minus 4 is equal to 1 by 3 dH2 by dt. Okay, now how we will find out this? Simply by multiplying with 3, right? It will be 2.5 into 3 into 10 the power minus 4. That much will be the unit. That much mole per liter per second. That will be your answer. That's why I told you in the initially that this chapter, if you get the concept clear, you could solve the problems in 2 or 3 steps, and you can easily score the mark, and also you can save the time during your board examination. So while preparing for your examination, don't skip this channel, and if you are feeling any difficulty, we will be here to support you. Okay? Now see, one more question from this concept. That is, for a reaction, 2H2O2 giving 2 water, 2 moles of water and oxygen. Here see, this reaction is taking place in 2 steps. Okay. So, for reactions that is taking place in a single step, we will call such reactions as elementary reactions. So, what do you mean by elementary reactions? Those reactions which takes place in single step. Okay. For this reaction, the mechanism of the reaction is given below and this reaction takes place in 2 steps. So, such type of reactions that the reaction takes place in more than 1 step, that type of reactions we call as the complex reaction. So, this is an example for a complex reaction that take place in more than 1 step. Okay. So, in the case of complex reaction, what you have to remember is, we will consider only the slowest step. That the slowest step is the rate determining step in case of complex reaction. So, keep in mind that for complex reactions, the slowest step will be the rate determining step. So, look at the third question. Out of step 1 and 2, which is the rate determining step? Here, it is clearly given in the question that the first step is the slowest step. So, that will be the rate determining step. So, keep in mind that for complex reactions, the slowest step will be the rate determining step. Okay. Now, see, write the rate law of the reaction. So, for complex reaction, we will be considering the slowest step as the rate determining step. So, how we will write the rate? Rate is equal to K into, for the slowest step, K into concentration of H2O2, concentration of I. Okay. So, if it is asked what will be the order of reaction in terms of hydrogen peroxide, it will be 1. What about the overall order of this reaction? It will be 1 plus 1, that is 2. Okay. I hope this order and rate law is clear for everyone. Now, let's see one more thing that is also very important, that is the molecularity of a reaction. So, molecularity means nothing but the how many molecules are there in the reaction. That may be atoms, ions or molecules, that reacting species is. Okay, how many, that is how much number of reacting species are there. That is what the molecularity. The number of reacting species is taking part in an elementary reaction. That we will consider the molecularity only for reactions that takes place in the single step. That is what elementary reactions. And in which must collide simultaneously in order to bring about the chemical reactions. Okay, see here, if a reaction is proceeding with one molecule, that is what we called unimolecular reactions. For ammonium nitrate, see, nitrogen and water is forming, there only one molecule is there. So, it will be a unimolecular reaction. In case of hydrogen iodide, see, there are 2 molecules. So, it will be bi. Bi means 2. Okay. Uni means 1. Bi means 2. So, bimolecular reactions, there will be 2 molecules in the reaction. Okay. For tri means 3. So, see here 2 nitrogen monoxide and 1 oxygen. So, this will be 2 plus 1, 3 molecules are there. So, did you get the difference between order and molecularity? Molecularity means number of molecules involved in the reaction. And order, that we get from the rate law, that x and y is the experimental data. We are finding the sum of that exponents and we are getting the order. Now, let's see the differences between this molecularity and order of a reaction. That is, order of the reaction is what it is? The sum of the powers of the concentration of reactant in a rate law. And molecularity is the number of molecules. Okay, number of reacting molecules that collides or that participate in the reaction. And I have already mentioned you that the order of reaction can have value 0 order. 0 order means reaction rate is independent of the concentration of reactant. And it can have values, integer values, fractional values. This fractional values mainly coming for the complex reactions. Okay, whereas whether this molecularity will be 0, that means there is no molecules, then the reaction will proceed. No, right? So the molecularity will be always greater than 0. It will be an integer value with value greater than 0. And we can see, we can apply the order of reaction for both complex as well as elementary reaction, but molecularity is only for elementary reaction. And we have already mentioned that order is a experimental quantity. So whereas molecularity is a theoretical quantity. We are measuring it by stoichiometric coefficient. Okay. So I hope it's all clear for you everyone. And for this question, the rate is given as rate equal to K. That means this is a 0 order reaction. And what about the molecularity? It will be 1 plus 1. So it will be 2. Now you try to find out the unit of rate constant. This is a 0 order reaction. And try to find out the unit of rate constant. Okay. With this, I am winding up the session and I will be coming with the second part of this chemical kinetic chapter soon. And one more thing, your Rahul sir will be coming on live on 6th September, Wednesday, with the second part of your physics class, that is moving charges and magnetism. So stay tuned with us. Thank you all.